I'm Professor Pi. Welcome to my daily mathematical adventures. Hey, don't forget me. I'm Cowboy Rufus. I'm your favorite student. Hi, I'm Cowboy Rufus, and Professor Pi says today that he and I, we're going to learn you all about quads. And I know all that because I had it in geometry last quarter. There's quadrilaterals, there's parallelograms, there's rhombus, there's rectangles, there's squares, these kites, and there's trapezoids. And I know all the properties of all those, so I'm all set to learn you all about quads. What? What? Oh, Professor Pi says that today we're not talking about quadrilaterals, we're talking about quadratics. I don't know much about quadratics, so I think I better get off the picture and let Professor Pi take over. That's right, Cowboy. It's quadratics, not quadrilaterals. And you did real well on the quadrilateral test. So I'm sure you could learn them. I think teach them might be better than learn them, but okay. Yeah. Today we're going to talk about quadratics on a graphing calculator. Our major objectives are A2, IF, A2, and A2, NQ, A.2. At the end of this, you should be able to say, I can graph quadratic functions on the calculator. I can find the maximum and a minimum of a quadratic function. I can solve quadratic equations by graphing, and I can estimate the solutions to the quadratic equations by graphing. Now, quadratic means squared. Everything we study this chapter is going to have an x squared term. Might have much more, but it's going to have an x squared term. So there is a little link to what you already know about quadrilaterals from geometry. What's the area of a square? The area of a square is s squared. That's where we get the squared term. All right, as again, my video is going up here. I got 3 other videos. If you don't get anything from mine, watch 1 to 3. All quadratic functions, the shape is a parabola, will cross the x-axis, or it won't. That is, it can cross at one point. At one point, it's exactly touching the x-axis one place. We would use that point once, but we're going to use it twice. So if the point were 1, we would have x plus 1 times x plus 1. We still have 2 solutions, but we're using the same solution twice. Most of the time when we graph this parabola or a quadratic equation, we're going to get a parabola that crosses the x-axis at 2 places. On your graph, these 2 places could be a whole number. Most of the time when we get a whole number, you can actually factor the quadratic. And we'll cover factoring again in case some of you have forgotten it from like Algebra 1 and pre-algebra, but we'll review it shortly. If you can factor it and your answers come out 1 and 7, then the parabola should cross the x-axis at 1, x equal 1, and x equals 7. Occasionally, we will get a quadratic that has no solution. This third one, it doesn't touch the x-axis. It's either way above the x-axis or way below the x-axis. It doesn't touch the x-axis, so we have no real solutions. I will tell you in this chapter how we find some imaginary solutions. Every parabola or x squared function has an extrema. Extrema are maximum and minimum. They go on and on forever in one direction, but in the other direction, they stop. Take a look at this one. The maximum, infinity. It goes up forever and ever. What's the minimum? It never gets below -1. And if you were doing this on the graphing calculator that you have in your hand, you put in an equation, and let's say you look at x equal -6. What happens when x equals -6? Nothing. There is no, the graph never gets that low, but on your calculator, what are you getting? Yeah, graph that function I have on the board. What are you getting down there? On the TI83 and 84s we have in this classroom, you're getting error. When x is -8, there's error. When x is -10, it's an error. It's errors all the way down. Sometimes you'll just see blank lines all the way down on some of the other models of the graphing calculator. There is no y equals -10. It never gets that low. How low does this one get? -1. It never gets below y equal -1. This other one here, the one on the right, it has a maximum and a minimum. The minimum, first of all, is infinity. It goes down forever. You can see this one's upside down compared to the last one. It goes down forever. But how high does it get? It never gets above 7. So that's our maximum. Today, you're going to try and find possible solutions. But if you can find the maximum and the minimum, then you have a pretty good idea. If I told you that the maximum here was 7, and if I told you that the vertex, that is the origin of our parabola, was at 2, 7, and I gave you 3 or 4 more points down this side, you could kind of fake the curve. You could, it's a parabola. If I give you like 5 points, you could fake the curve. Just like the one behind me, you could fake the curve. That's what I mean by up here where it says we're going to approximate or estimate the quadratic equations by graphing. Graphing is great if it comes across and it comes across right at, like this one does. This one comes right across at 5. Now, if we get our parabola to cross the x-axis at 2 and 7/19, got no chance of graphing that. We'll have to solve it some other way. But if it crosses the axis at 7 and at 3, we can find that equation. Now, here's the keys you're going to need for your graphing parabolas on the TI83 and 84 models. You're probably quite familiar with this because we've already graphed straight lines on the calculator. We've done systems of equations on the calculator. You know where the y equals button is? It's up here. The x button, when you need it, is up there. Negative is not the same thing as subtract. It is in Algebra 1, but on your calculator, there's a subtraction key and there's a negative key. So if it's a negative x out front, negative x squared out front, you need to use this negative key, not the subtract key. The rest of the equation, like in this one, x squared minus x, that's going to be the subtract key. Minus 12 is going to be the subtract key. But on this equation, right there, it's a negative x squared. Now, the other key you're going to need is, we call it the hat, we call it the roof. On a regular typewriter, it is Shift 6. On your calculator, it is right here. That's going to be our exponent symbol. So y equal x squared is the first one you're going to graph. So let's graph y equals x squared. Now I've gone to my demos calculator because it shows up better on the TV screen. You do it first. Everybody put in y equals x squared. Remember, to get the 2, you're going to have to do this. On some of the newer models of calculator, you can simply hit the up key and put the 2 in as an exponent, hit the down key and come back to the regular line. So I got y equals x hat 2. There's my parabola. What's the vertex? What's the bottom center of my parabola? Just like the vertex of an angle, we have a vertex down here. Our vertex is at 0, 0. It starts at 0, 0. That's the only part of x. This is the parent function. We learned a chapter or two ago about parent functions. If you find the parent function, you can always figure out what's happening with the next transformation. So let's do another transformation. What do you think happens if I make this negative up here? If I just shove in a negative sign, what's going to happen? So I want you to graph y equals negative x squared. Yep, if you put it negative, the parabola now is going down. It has no minimum. It goes down forever and ever. It does have a maximum. The maximum would be 0. All right, let's go in again. I want you to graph x squared minus 4. And before I do that, somebody guess with the minus 4, what's happening with my parabola? I think you're right. Let's find out. Yes, we had the parent function was, let me put the parent function back up here. Y equals x hat 2, and the hat on your calculator once again is on the top right, just above the 3. Yeah, that's it. Now, the parent function was up here. I had the same exact function. All I did was drag it down 4. The next one we're going to graph is make this a plus sign. The parent function is here in blue, and your function, when you add the plus sign, yes, that takes your parent function and it moves it straight up 4. Now, what happens if I make something in front of the x? How would you make the parabola wider? Do you want me to put a fraction in front of the x or a whole number in front of the x? All right, I have the parent function again. It's still in blue. How many functions you see? Only one, because it's the same equation. But let's put a 4 in front of the x squared and see what you get. Yeah, some of you thought that would make it wider. That didn't make it wider, did it? The blue one is the parent function, y equals x squared. The red one, when I put that 4 in front, you thought it would make it wider? In a day or two, you'll see why it did not. So yeah, you're right. There's only one question left. That is, if I make this a fraction, is it going to make it wider? 1 divided by 4. Yes, the fraction makes it wider. And if we get around the plotting points on your calculator. Now, do you have that one in? Let's go to second graph, get that table, and you'll see 3 specific points on your table. 0, 0 is there. 4, 4 is there. And negative 4, 4 is there. If I gave you those 3 points and told you you have parabola, could you fake the rest of the curve and find the curve. Most of the time, we're going to graph the quadratics. Our quadratics are going to be in standard form. You've seen standard form several times, starting with pre-algebra. We have an x squared term, then we have an x term, and then we have a constant term. So the one I want you to graph last is x squared minus x minus 12. X squared minus x, 1x, minus 12. Let me get rid of the parent function temporarily. Now, is x squared minus x minus 12 something you could factor without a calculator? I need two things that multiply to 12, and this is a subtract sign, right? I need two things that multiply to 12 and subtract and get minus 1. Yes, it's x and 3 and x and 4. And why did I say it like that? Because you got to figure out which one's the plus sign, which one's the minus sign. In our case, this is x minus 4. You're right. X minus 4, x plus 3, which makes our solutions minus 3 and 4, because you got to set them equal to 0, change the signs. Where's our parabola crossing? At minus 3, 0, and at 4, 0. So you already know a whole lot about quadratics because you remember how to FOIL and factor. And just in case you haven't, I will start with the very basics tomorrow, and we'll talk about FOILing and factoring. That's all I need you to know about parabola today. You have a worksheet where you're going to graph 10 or 12 other functions for me and sketch the graph that comes off your calculator. Thanks for watching another Professor Pi video. Yeah, y'all come back tomorrow. Cowboy Rufus and Professor Pi will teach you something new.